Good afternoon. I'm Tyler Fairchild. Today we're going to be going over what we call decision trees. So let's pretend it's Saturday morning. You wake up and it's raining outside. You come to the conclusion, I planned on going to the beach. But wait, it's raining. I don't have a good time at the beach. But I do have a good time watching Netflix, or I do have a good time reading a book, or I do have a good time going to the gym. Now, I enjoy going to the gym more than I enjoy reading a book, or I enjoy going to the gym more than I enjoy watching Netflix. But after going to the gym, I might go to Netflix. So what are we doing here? What's our mind doing when we say, I'm going to do this, and here's the reasons why, and here's the escapade of the decisions of how I'm making these decisions. So what we're doing in our brain is called if-then. If I enjoy going to the gym, then I'm going to go to the gym. If afterwards I want to go watch Netflix to rest, I'm going to go home and watch Netflix and rest. So this is kind of the escapade of how decision trees work. Decision trees end up being the backbone of a lot of a lot of AI, what we call boost classifiers, we call random forest. These scale of models, right, are all built on the backbone of decision trees. So today we're going to go through a simple decision tree classifier that is used on what we call the Titanic dataset. The Titanic dataset can be found on Kaggle, and here's what that looks like, right? So if you go to Kaggle, type in Titanic, you can find 5,000 different data sets, right, that have code or that have data that can be downloaded, right? So you'll go in, you'll find maybe the test and the train set. You can see the elements that we're going to be working with. So passenger ID, survived, age, fare, different kinds of priority class, the family size, and so forth, right? So that's the data set we're going to be working with. So we're going to go ahead, start here with bringing in our libraries that we're going to be using. So pandas, NumPy, some of our scikit-learn packages, matplotlib for creating some visualizations. So we're going to start off by reading the data frame and first read it in. We see here we have, just like I showed you in the Titanic dataset, passenger ID, survival, gender, age, the fare paid, the priority class, the family size, and so forth. Now for this experiment, what we're going to do is we're going to focus on only a few of these features. We're going to focus on priority class, all of the fields. We're going to focus on age, sex, fare, all as features, and then survived as our target outcome, right? So we're going to go ahead and say data frame, we're going to keep just our columns. Now we've established to keep, and then present the header. So the first 5 rows that we get back, right? So now you can see, okay, we're shrunk this down. We're only focusing in on these few columns now, right? We're then going to go in and we're going to split our data frame into a X and a Y, creating an X and a Y axis, if you will, right? So then we're going to go on and use our package train test split from our scikit-learn model selection library, and that's going to split into our X train, our X test, our Y train, and our Y test. That's going to give us our training and our data and our test data sets, right? So we're going to split this with 60% going towards the train and 40% going towards the test. So we're going to start off by training just a simple decision tree. We're going to say model equals decision tree classifier, maximum depth of 3, the random state of 42, and then we're going to fit that to our train data. So let's stop here and talk about this max depth. So whenever I spoke about with the first analogy at the beginning of this video, where I said I'm going to first go to the gym, then I'm going to read a book, and if I enjoy reading a book, I'm going to maybe want something to drink while I read a book to help pass the time. if I enjoy hanging out in the living room and reading a book, I may end up watching Netflix. So all these things are flowing into these different layers, if you will. So we have our first if then, our second if then, our third if then that takes place. Think of it like a flow chart that, based off decisions, could go one way or the next, right? So this max depth is telling us that we're going 3 layers deep with our model, right? So that's how we're initially fitting our model, with 3 layers. So maximum depth of 3. Now we are going to use the model to predict against our test, and that's going to bring back a 82% accuracy. Now, while accuracy is a good judge, there are better judgments, and we're gonna get into those in just a minute. But first, we're gonna visualize our tree. What does our tree look like? So we're gonna plot our tree. We're gonna say plt.figure. Again, we brought that in from matplotlib pyplot as plt, right? And then we're gonna say plot tree, and then it's gonna be model featured names, and we're going to have our featured names as our columns, and then our class names as did survive or did not survive. And then we are going to say fill equals to true, and again that survive or did not survive, that's coming from this column we defined as our target whenever we created our y, right? So 0 equals did not survive, 1 equals did survive. Okay. So let's go ahead and look at what this decision tree looks like, and think of it in the same scheme of how I spoke about my what am I doing today? How do I make that decision when it's raining outside? And I know that these are the indoor activities that I enjoy. So here we have where we first analyze is sex less than or equal to 0.5, and then it goes down based off that conclusion. Is priority class 3 less than or equal to 0.5, and then it goes down after that conclusion. Is fair less than or equal to 0.046? Is age less than or equal to 0.044? And so forth. And same with the other side of the tree. Is age less than or equal to 0.081? True, left side. Not true, goes down the right side. Priority class 1 less than or equal to 0.5, priority class 3 less than or equal to 0.5, and so forth. And that's how it ends up going about the data. That's how the model ends up sequencing through our data. All right, so just to provide a quick visualization of what that tree looks like. Right. Now, as we go just a little bit further, I wanted to demonstrate in this video what it looks like for the model to overfit. So we spoke briefly about how this max depth worked. So max depth of 3, we're going down 3 layers. Now, what if we let the model itself make its own decision about how many layers it needs to go down? So we're going to do that here with our deep model is equal to decision tree. Not going to put anything in here. We're not going to put any levels in there. So no max depth, only putting in our random state. And without putting in our max depth, it's going to assume the max depth. Or it's going to not go any kind of depth, right? It's just going to come from the top. So our deep model dot fit, deep model dot predict, where we're predicting against our test again, and we're getting our new predictions, right? So just in comparison, from our original model, or I'm sorry, against our test data, we performed at 0.76, and in our training data we performed at 0.98. So what that did is it said, okay, we can perform very, very well on our training data, but whenever we see new data come in, it's not going to perform quite as well, right? That's what it means by the term overfitting. So we're overfitting. Now, underfitting would mean we don't perform well on the training data, and we do perform very well on the test data, right? Now, here just to show a confusion matrix. Confusion matrix, we're saying on our left side is our true labels, our right side or our x-axis is going to be our predicted labels, and from here we can see is the top left box is going to be our true negatives, and on the bottom right is going to be our true positives, right? So our top left and our bottom right corner is going to be where we were accurate and where we predicted correct, right? So we predicted 174 as true negatives and 87 as true positives, right? To go one layer deeper, right, we are going to look at what we call a ROC AUC score, primarily focusing on this AUC. So what this AUC does is it gives a general standard as the most optimal way to judge a model. The goal is for this number to be as close to 1 as possible. So you can see here what we did is we brought in, and we're using ROC AUC score from scikit-learn from the metrics package or module, and we are using this against our Y test and our Y probability. We are then gathering FPR, TPR, and using this in our plot, and then using our AUC that we got from our ROC AUC score. And we can see the output of this presented as 0.869, which is a very well performing score for a decision tree classifier. So that is all for this video. Next, we're going to go through some XGBoost model and how that operates. We're going to go through how a random forest model operates. But with that said, this Jupyter Notebook will be posted into my GitHub and in the link of this video. Thank you for joining me. Have a great afternoon.